Okay, so bye. Let's start in like another 2-3 minutes. Can you guys can you guys see my screen?
Yeah.
So let's wait for another 2 minutes so that okay, so meanwhile we can recap I think what we have discussed. So in the first class we have discussed the basics, right? So we have discussed mean, median, mode, and then we have discussed range and standard deviation, right? So these concepts are very, very important because they keep coming in another form. For example, some other concept is using, for example, PCA is using variance or standard deviation, or let's say some other formula is using mean, median. Let's say you're replacing NA values, right? So you will be using median, for example, for continuous values. Let's say there is a categorical value like unemployment status, or let's say gender, then for replacing the NA values, you'll use mode, right? So which is the most frequent value. So the idea behind the first class was to make sure that you understand these basics well, because these will be used in another form, for example, not in the straightforward form. So you will not get a question saying that these are the numbers, can you find the mean or median, but you will get, or you will end up in a situation where you'll start understanding, okay, so this is where I will start using median, for example, replacing NA values, right? So the mean, median, mode, and range and standard deviation. So it's very important to keep those ideas always clear. Like if you have any questions, just let me know. So before we go further, for example, mean is just summation of the numbers and divided by the total of the numbers. The key difference between mean and median is you sort the numbers in median and you find the middle one. Mode is the most frequently occurring number. Range is basically your maximum minus minimum. And then standard deviation, you have that long formula, square root of x minus mu whole square divided by n if it is population. And if you're talking about sample, it is square root of x minus x bar whole square divided by small n minus 1. Okay. So these formulas you should just remember top of your head. And then we started discussing more about probability, right? So what I mentioned in the previous class is whenever there is a probability, there will be a random variable, right? So this is important. So wherever there is some randomness or some sort of chance is associated, so that's where the probability will generally come into picture. Okay. Now, some of the random variables that we have discussed is the first one is when you flip a coin, right? So this is a random variable because the outcome could be heads or tail. The second one that we have discussed is roll a dice. So this is another example of a random variable, right? So some more examples were like, for example, the content. So these are discrete ones, right? So these are called discrete random variables. So discrete. Whereas the continuous ones are, let's say, the weight of my body, right? So today I'm, let's say, 68.5 kgs, tomorrow 69, suddenly 67, right? So let's say you can say the amount of traffic on the road, right? So how many vehicles, like right now there are like 7, tomorrow suddenly 8, and so on, right? So like that. So these are the different, so the basic idea is wherever there is some random variable, there is an event, and then there is probability associated with that. Now, the classic definition of probability is how frequently we expect the different outcomes to occur. So this is a frequentist approach. So this is a little bit confusing. So I'll just explain you in simple terms. So generally you can break down probability always in this particular manner. So you come up with the divider. So basically your sample space. Now sample space is basically all the total events that are possible. Okay. And on the top is where you'll basically look for favorable outcomes, right? So let's say this is favorable meaning, so there will be some question, right? So this happened and this is what you have to figure out. So you are looking for these, whatever the favorable outcome that they have asked in the question. So generally you start with the denominator. That's a good practice, because if you make mistake here, then the whole thing is gone. So generally you start with the sample space. So the definition of sample space is all the events that can occur. All right. So when you flip a coin, so the sample space is basically head and tail, because these two events can occur. All right. So when you roll a dice, so the sample space is like something like this. So 1, 2, 3, 4, 5, and 6. Right. This is the sample space for deck of cards. So let's say deck of cards. So the sample space is something like 52 cards are there, right? So dot, 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 52 cards, right? So this is a sample space. So whenever you get a question, first you figure out what is the sample space, right? So that will make your half of the work finished, right? So let's say half of the work is done, because if you get this divider part correctly, so let's say if you're working with a deck of cards and then you draw one card, so you'll divide by 52, okay? And then you will look at the numerator. Let's say they're asking queen, and then let's say they are asking queen of diamonds or something like that. So based on that, you look for the favorable outcome. So how many of that out of those 52, how many of them are favorable for the question that they're asking? So this is a general approach for probability. So any questions till this point on these things before I proceed to the other concepts? So I hope the basics are clear, right? So the basics are like, there is a random variable. So this is the flow that is important to remember for machine learning's perspective. So there will be a random variable. Sorry. So there will be a random variable. Okay. So these things we'll discuss slowly, but I'll explain like end to end what is the connection with machine learning. So there is a probability associated. Okay. So there is a probability whenever there is a random variable. Okay. Now, so one of the extension of probability is basically so conditional probability. So we'll discuss all of these. Don't worry. I'm just explaining the flow. So conditional probability. So the extension of conditional probability is called Bayes theorem. Okay. So these are all simple. You don't have to worry a lot. So Bayes theorem and the extension. So till here is probability. So till here, whatever you learn here is probability. And the extension or the use of this is Bayes theorem is generally used in one of the machine learning algorithm called naive Bayes. So naive Bayes. So the red color one is your machine learning side. So this part is machine learning, and then till here is your basically your basic probability and statistics. Okay. So these two concepts are interrelated or used, right? So first you have to identify what is a random variable. Then there will be a probability associated with that. If two events or one event has already occurred and one event you are looking for the second event's probability, that is called conditional probability. If you have more than 2, 3, 4, 5, then you will use Bayes theorem. So till here is what you learn in probability. Now, once you start machine learning, you will start understanding how do you connect the dots. So machine learning has an algorithm called naive Bayes. So naive Bayes algorithm is internally using Bayes theorem. I hope that is clear. Any questions on this at this point? I hope you guys are with me. You guys can hear me, right? You can just type in the chat, or you can just.
Yes, Mani.
So any questions at this point? Anyone? Okay.
This condition, hey, Mani, just one doubt. Maybe just I thought it in my mind like this. This conditional probability is only used as naive Bayes because if you want to predict the house price again, many parameters would be given and then you predict the house price. In that case, also it's like a conditional probability itself, right?
Right. Because the features. So what you want to predict is the house price, right? So that is your target variable. and whatever the features are already given is your features, let's say number of bedrooms or let's say all that. So that is your already, so you'll figure out the probabilities of that beforehand. So conditional probabilities, basically one event has already occurred and you're trying to predict or you're trying to figure out the probability of the next one. So we'll see an example, so that will make it more clear. Okay.
Okay.
So I think we have covered these basic definitions. So today I'll just cover both definitions and maybe we'll do some small problems and then you guys will get a hang of it. So we have discussed about basic probability. We have discussed what is a discrete and continuous. For example, if the outcome is dead or alive or dice or counts, that is discrete probable variable, random variable, sorry. And continuous is, let's say, blood pressure or weight or let's say speed of a car or amount of traffic. And these are the some of the important things that you have to remember. The probability function will always have values from 0 to 1. It cannot be below 0. It cannot be greater than 1. Okay. And this is just a pictorial description of what is a probability when you roll a dice. For example, when you roll a dice once, so the probability of it falling on 1 is 1/6. At the same time, the probability of it falling on 2 is also 1/6. So what they're trying to explain is when you add these individual probabilities, the summation should always come up to total is 1. Okay, so this is an example of discrete one. Okay. Now this is generally called PMF, which is called probability mass function. So probability mass function is nothing but the same thing that I've shown in this graph. So what they're explaining is in the form of a table. So P of X equal to 1. So this notation is important. So this is the probability notation and X is the event, and 1 means you're looking for, you rolled a dice and you're looking for the favorable outcome, which is the dice is falling on, let's say, the face 1. Right. So this is a dice. So generally there is 1 here. Right. So this is what it means. If there are 2 dots, this notation means that. So P of X equal to 2 means that you roll a dice and you're looking for you're looking for the dice to fall on the face which has 2 dots, which is X equal to 2. Okay. So all of these individual probabilities are 1/6. Okay. So probability mass function, and the summation will always be equal to, total is will always be equal to 1. So these are a little bit theoretical ones, which are easy and good to remember because sometimes. So can anyone tell me where you can use this? So for example, let me only tell. So for example, you know probability of these, so you can figure out this is basically 1 minus 5/6. So something like that. So let's say if you know the individual probability of, let's say, A, B, C, and you know there are 4 events in your total sample space. So you don't have to find the probability of A, B, C, D. Once you find the probability of ABC, you can do 1 minus D, A plus B plus C, that is a probability for T. So that is where you generally use this idea. Okay. So this is called your probability mass function. So this is another theoretical concept called cumulative distribution function. So CDF is nothing but you add them, right? So for example, the probability of 1 was basically 1/6. Now when cumulative, right? So whatever the value you get, you keep on adding to it. So the probability of 2 was also 1/6. But since this is cumulative, what you do is you add the results so far. So basically this will become 2/6. This will become 3/6. So you keep on adding whatever the result was already there. 4/6, 5/6 and 1. So that is also explaining that the CDF will always end up at 1. Right? So this is one more concept. So these generally will be used in theorems and all that, but generally it's a good idea to know. Okay. Now let's solve one problem together. Okay. So I'll just give like 2-3 minutes for everyone to read this particular problem. One second. Yeah, there is no way to hide. Yeah. So can you guys first read this particular problem and explain me like what is the situation, what is going on? Just a general understanding. What do you guys understand from this particular problem? What is a random variable here? Is probability even applicable here? First thing. Can you guys just take 1 or 2 minutes and then just let me know? Like the question is probability, does probability even apply here, and what is a random variable? Any questions? Any questions so far? Like, I hope you guys are with me. So what I'm, so if you read
Yeah.
this, yeah, if you read this particular sentence, the first question that I have is there any random variable? Because I've told that there is a random variable associated with probability, right? So is there any random variable here? If there is a random variable, can you explain me what is that random variable? What is that given according to the question?
Random variable here is number of patients coming in an hour.
Okay. Now it is a random variable because,
Because we will find the probability of coming, means how many patients are coming in an hour.
right? So because we don't know, right? So there is no fixed number of patients coming in.
Yes.
Sometimes 10 patients come in, sometimes no patients come in, sometimes maybe 15 patients come in, right? So it's, so first thing is it is important to understand what is the random variable that is given in the question, right? So that is good. So the first half is done, right? So figuring out what is a random variable. So now we know that, okay, yeah, Mani, there is some probability associated. So what does this particular table explain? So this table explains the prob. So some person was bored and then he sat down and then he started noting down all the people, let's say, for past 5 days, and then he calculated that, okay, this is the table I came up with money. Then I have some questions. So that's what he asked. So for example, x equal to 10, which means that there is a 40% probability that the number of patients that are coming in the next hour is 10. Okay, so the way you interpret this particular table is basically x equal to 10 means, so in the next hour in this ER room, emergency room, there is a 40% chance that 10 people will come, right? So there is only 10% chance that 14 people will come, right? Now, what is the probability that 15 people will come? So what is this probability?
0.
Right? So 0, because now had I told you this, if you remember, right? So the probability summation, right, is already 1 here, right? If it was not 1, then I would have told that anything that is outside of this would be 1 minus that probability. But since the summation of these individual probabilities already coming up to 1, all the remaining probability 15, 16, let's say 9, let's say 8, all of those probabilities are 0, right? So I hope that makes sense. So that is how you interpret probability, right? So that is how you interpret the table that is given here, and that is how you interpret the probability. So let's say the probability in the next hour, there are 12 patients in the ER room, is basically 20% or 0.2. Okay, so I hope the question is clear. Anyone has any?
Yeah, I have a doubt that I just want to know that for the next hour, for the random variable number of patient is coming, like that first column, if I would ask, the number of patient in the next hour possibility will be 10.
Okay.
Then how come, means I can explain the question like in the next hour that 11, 12 and 13 and 14 events are occurring. Means how can I understood this question? In my term, I can understand that in next hour the patient in the ER room is like 10. But how can I explain like 11, 12 and 13, 14? Means actually I didn't understand the question what it is asking.
Yeah, so the question is, so let's say there are ER room, right? So ER room is basically, so what it means is, if you take the simple idea here, for example, there is heads and tails, right? Both of them are there on the coin, right? But when you flip a coin, only one of them can occur, right? So it cannot fall on head or tail. It will fall either on those, like maybe head or tail. At the same time, when you take a dice, so it already has 1, 2, 3, 4, 5, 6, all of these faces, right? So I hope you have seen the dice, right? So dice already has this, but when you roll it, right? So when you roll it, it will only land on one of those faces. So this point is clear, right? Any questions on this?
Yeah, it's clear.
At the same time, so this ER room, any number of people can come in. So let's say sometimes there are 10 people, okay, sometimes there are 11 people, sometimes there are 12 people inside this, okay. Now who is looking this? So some guy, so let's say on January 1st, let's say January 1st 2020, okay, and till January 5th 2020, every hour he is noting down, right? So let's say 12 o'clock there are 10 people, okay, 1 o'clock there are 11 people. So like that he has collected the data, right? Now once he has collected the data, he has calculated these probabilities also. Now what this means is in the next hour, right? So at any point of time, let's say if you take June 1st, right? So if you take June 1st 2020, let's say the hour is, let's say 3 p.m, right? So what they're trying to explain is, so the ER room is empty right now, let's say, okay. So they're explaining that the probability of let's say there are 12 people in this ER room. So let's say 12 people come for emergency, they have injuries, that they are saying the probability is only 20%. There is a 20% chance, right? If 100 times this happens, only 20 times there will be 12 people. Remaining times, let's say out of those 100 times, 10 times will be, there will be 13 people. And then let's say 10 times there will be 14 people. I hope you're understanding what I'm saying.
Yeah, I'm getting.
At 1 hour, of course, there will be only fixed number of people. Because when you throw a dice also, it will only land on 2. But of course, it has chance of falling on 1, chance of falling on 3 also, chance of falling on 4 also, 5 also. In the same way, the ER room can also have, let's say 100 people also. But what they are saying is, there is a high chance that there will be generally 10 people, right? So generally you can say like high chance that this restaurant will be open. So what you're explaining is there is a maybe 60% chance that this, or probability that this restaurant is open, right? So that's what you're saying. So in general, if you forget this point, you will say that if you keep looking at this ER room, so you'll say that, okay, yeah, so generally I see 10 people in the ER room. So that's what people say. But that generally you can make it into probabilities, right? So you can exactly say there is 40% chance, right? I hope that makes clear.
Yeah, that's clear. Means we can say like that for a particular event, whatever number of patients are there for to the corresponding hours, this is presented in X, and corresponding to that probability values are in the below, in top of the below.
Is given, correct. So that's good.
Yeah, clear. Thanks.
In a given hour, that is important.
Yeah.
So let's take some questions. So the first question is, what is the probability? Find the probability that in a given hour, exactly 14 patients arrive. Arrive meaning because they have some emergency, let's say some injuries. So that's why they came. So that is already given in the table. The answer is 0.1. So any confusion on this first question? Any questions on this? So the question is, find the probability that in a given hour, exactly 14 patients arrive. So which is basically 0.1. Okay, so that is your first answer. So the second and third questions are a little bit tricky. So take your time and don't jump to answers directly. People directly jump and then make mistakes. Take some time, break it down, and then you apply. So the second question is, at least 12 patients arrive. So can you guys think on this? Answer is there, but I want you guys to think on this. So at least 12 patients arrive. So let's say someone is sitting there and then looking at the ER room. In the next hour, he already knows this probability. The question is, at least 12 patients arrive.
Yeah, it's 0.4 because at least 12% will be when it's 12, 13 or 14. So
Okay.
summation of that will be 40% chance.
Anyone has any doubt or confusion on this?
Because 10 and 11 will be less than 12. So we will always consider 12 or more than that.
Right. It's a good answer. Anyone has any doubt or confusion? At least 12 patients meaning, so there could be 12, there is 13, there is 14, there is 15 also possible, but we know the probability of 15 is 0, so there is no point discussing that. Given this particular table, so at least 12 patients arrive. So basically P of x greater than or equal to 12. So basically you summation, or you basically add all the individual probability. So basically you add this one, this one, this one. So you add probability of at least 12, means 12 can come, 13 can come, or 14 can come. So basically you add 0.2, 0.1, 0.1. So total is 40. So there's a 40% chance that in the given hour, so let's say in the given hour, there is at least 12 patients, right? So there's a 40% chance that there is at least 12 patients. Any doubt or confusion at this point? Anyone? Okay. So what about this one? So at most 11 patients arrive. I hope you guys understand the convention, at least, at most.
Yeah, so first to 10 or 11 we'll consider.
Right? So at most means only 10 or 11 patients can arrive. If 12 patients come, that is not correct. Right? So at most means only 10 or 11. Now we already know the probabilities of 10 and 11, so which is already given here. So it's 0.4 and 0.2. So you add these two values. So basically you get at most 11 patients. So at most 11 patient means it could be 10 or it could be 11. So since it could be any of those, so you add those individual probabilities. So the final answer is 0.4 plus 0.6. So there is a 60% chance, that there will be at most 11 patients in given hour. Okay. So I hope this question is clear. Like, this is a simple problem. So this type of problems you can expect in your, let's say interview, or let's say design, or let's say someone is basically trying to check how much probability you guys understand. Is this problem clear for everyone, so that I can move on?
Yes, it's clear.
Okay. So let's go to some other basic concepts. So this we have already discussed. So probability is basically between 0 and 1. Event is basically when I throw a dice or something. So simple event. So this is important, right? So simple event is basically rolling a dice, right? So rolling a dice, okay, or flipping a coin. Okay. Now simple event is basically I'm only looking at one thing, right? So what I'm looking at one thing in rolling a dice is basically what is the phase that is falling on. Right? So what is the phase it falls on? Is it like 1 dot or 2 dots or 3 dots? When I flip a coin, I'm only looking like coin will fall on head or tail. So like only one characteristic is the answer. So simple event is basically an event that can be described by a single characteristic. Okay, so this point is important. So sample space is basically collection of all the possible. So these definitions are very basic. Okay. Now this is another some theory, so it's okay. You just have to remember this. So there are three approaches of assessing the probability of an uncertain event. So a priori, classical probability. So the probability of event is based on the prior knowledge of the process involved. Okay. Now empirical is basically the probability of the event is based on observed data. Okay. Now, so for example, if you take the emergency room example, you do not know how many will come, right? So person will basically collect the data, and once you collect the data, then you come up with the probabilities. So that is the example of empirical probability, empirical classical probability, where you do not know the process. What about a priori? A priori is basically when you flip a coin, right? So you already know what will happen when you flip a coin, when you roll a dice, right? So dice roll. So you don't have to collect any data because you already know what is the process. When you throw a coin, you know what will happen and what are the outcomes. So this is generally not required. So subjective probability, which means the probability of an event is determined by individual based on the person's past experience, personal opinion, and or analysis of the particular solution. So generally what happens is, this is where a lot of importance is there, because people start collecting the data. So once the data is there, you can look for probability, right? So this is generally not required. This is only for your MCQ questions or something like that. So this is generally not so important. So these are the basic differences of types of probability. Okay. Now, in case of a priori classical probability, so the probability definition is given as the number of ways the event can occur divided by total number of possible outcomes. So in case of empirical classical probability, the number of favorable outcomes divided by total number of observed outcomes, right? So you can connect the dots here, right? So for example, so here I already know the favorable outcomes, which is head and tail. But in case of ER example, which is emergency room, I had to basically see what are the favorable outcomes. So favorable outcomes was exactly 10 patients, etc., etc. So all those things, right? So this is your empirical classical probability. So in this case, you generally collect the data. Okay? Collect data. And the only difference in this a priori is you already know what will happen, already know the head and tail, or let's say 1, 2, 3, 4, 5 in your dots. So that is the difference. The idea is always same. First, you start with denominator, sample space, total, and then favorable outcomes on the top. Okay. Now let's do this particular example. So before that, so let me show you. I don't know how many people know this. So this is a deck of cards. So there will be a lot of discussion on this. So a deck of cards is composed of 52 cards. Okay. The first top row is called diamonds, and it starts from A and then goes from 2, 3, 4, 5, 6, 7, 8, 9, 10. And then there is Jack, there is Queen, and then there is King. Right? So these are 13 cards, right? Similarly, the second one is called Spade, and this is black color. So A, 2, again same Jack, Queen, and King. The third one is basically called Hearts. It starts from A and then goes to Jack, Queen. And the last one is basically called your, what is the last one called? I forgot actually. This is Diamond, Spade, Heart, and Clubs, I think. Or I'm saying ulta. 1 second. So let me clear it up.
Diamond, clubs, heart, and spade.
So this is diamond, this is club, this is heart, and this is spade. So that everyone knows how many cards are there, what type of cards. So how many red color cards are there? So out of these 52, how many red color cards are there?
26.
26.
There are 26 red color cards, 26 black color cards. So how many face cards are there?
12.
Face cards, don't consider A as face. This is these are your face cards. So 3 plus 3 plus 3 plus 3. How many queens are there?
4.
Oh,
Right. So I hope you guys are familiar here with this basic. So just keep this picture in your mind so that we can solve some problems. So let me go back here. So the question is, find the probability of selecting a face card from a standard deck of 52 cards. Right. So I know, of course, everyone knows this answer, but it's a good idea to start from the denominator. So the denominator says that there are 52 total cards, and then one card is drawn. Right? So you draw one card. So all of your cards are like this. So let's say cards are like facing down. Right? So you draw one card from the center. Something like that. Now the question is selecting a face card. They have also explained what is a face card, which is Jack, Queen, or King. Right? So there are how many total number of face cards? Total number of face cards are basically 12. So the probability of drawing one card, which is a face card, is basically 3 by 13. Is it clear for everyone? Any question? If you have any question, just let me know so that we can discuss now. Later it will be a little bit tricky and then it will become double. For example, we'll do 2 things at one shot. Okay, any questions?
It's clear.
Okay, so 52 is your denominator. You start with your denominator, total cards, and 12 is basically your face cards. Okay. So what is the probability of drawing one card? And it is Queen of Clubs. Same question, similar question. So what is the probability?
1 by 13.
1 by 13.
1 by 52.
Yeah, so denominator gone, whole answer gone. So 1 by 13. Okay, I think. Okay, so the question is probability of drawing drawing queen of spade. Take some time, don't jump to answer because already I can see mistakes happening. I just draw one card.
1 by 12.
Okay, 1 by 12.
1 by 52.
Yeah, whoever has told 1 by 12, 1 by 13, can you explain why? How did you get there first?
In that spade, total number of cards will be there 12, and out of that, the queen, what we have to draw. So 1 by 12 it should be.
1 by 12, okay. If you told 1 by 13 also, I would be like, okay. That is a wrong answer. So what I'm saying is I have a deck of cards, right? So the deck of card is basically always 52. Now the question is I draw one card from the deck of cards. And the question that I'm asking is what is the probability of drawing exactly queen of spade? Now think whoever has told 1 by 13.
1 by 52.
1 by 52.
No, it's okay. If you make mistake, it's fine.
It's 4 by. Okay. Spade means 1 by 52.
1 by 52.
Yeah, 1 by 52.
I have a deck of cards. I'm drawing one card. And the question is, what is the probability of drawing queen of spade? Now, can anyone tell me, is there any other answer than 1 by 52?
Spade is what? Group of 12 cards or the whole cards?
This is spade. Where is spade? This is spade.
So sample space is 52 and queen of spade is only one card in out of 52. So
Yeah, right. So that's what I've been explaining, right? Start from the denominator. So denominator is 52, total number of cards. So I told I have one deck. I have one deck. I'm drawing one card. What is the question? What are the favorable outcomes? I want queen of spade, right? I'm only drawing one card. But what I want that card to be is exactly this card. Only this card. I don't care about spade. I don't care about hearts or black, whatever. I just want this card, right? There is only one favorable outcome.
Sorry, but I am confused with the question. Here the question is drawing queen of spade. So I was thinking the total number of card of spade. How many times that queen will come? So that's why I was thinking like 1 by 12. 12 is the total number of spade of the cards.
12, nahi, 13.
Sorry, Achha, this is 13.
1, 2, 3, 13, right?
Ha, yeah.
Now, for your answer, I will frame a question. Probability of, so I have probability of drawing a queen card from only spades.
Okay, yeah, got it.
Now, what people do is you start the problem here. I've been telling start the problem here, right? Only space is your sample space. Now, what are the only spades? Only spades are 1, 2, like that, 13. First you come with 13. Right? What I told, I have a deck of cards. So your sample space is this whole thing. It's important to start from the denominator. To start from
So your previous problem, right, Mani?
Yeah.
It can be asked the probability of drawing any card or probability of drawing a queen of spades. It's same. 1 by 52.
Any card. What do you mean by any card? Like it should have something.
Any random card, I'll say, or it is just any card. Right? Okay, so like that it becomes.
No, probability of drawing any card is 1, right? So obviously you'll draw a card, right? So there is, what do you, I'm not understanding, like how can you, so let's say I draw a card, right? So it is a card, right? So I will always draw a card. So probability always will be 1.
Oh, it is 1. Okay.
Yeah, it is 1, right? So let's say if I ask you a question, when you flip a coin, it will either fall on head or, right? It will always either fall on head or tail. There is, of course it will, one of them always will occur, right? Unless the coin is in the air all the time.
Yeah, yeah.
Any other confusion, doubts before I
Yeah,
jump?
means we can predict that the total number of spread by that what you said mentioned very clearly that only.
Correct.
Okay. Yeah.
You have to understand. Yeah, I understand the confusion why you guys are getting confused. Now, I don't want to confuse you more, but always break it down into 3 parts, right? Or maybe 2 parts. First part is what is your denominator, right? So I've told that clearly there is a deck of cards. Now, sometimes what happens is people try to confuse you and all that will happen in the exams and all the assignments or interviews. So you should always be clear that what is the sample space, right? So imagine that we are playing cards and there are 52 cards. Now, probability will always be that a denominator is 52, but they will twist the question that I have a deck of cards, or they will say that I have 26 black and 26 red cards. Of course, all of that is again 52 only, right? So you should not get confused by any of that, anything that they say like that in a different way. All you have to understand is what is given to me, right? So what is the sample space? So the sample space is all of this can occur. When I draw a card and close my eyes, any of the card can come. But what are the favorable outcomes? I'm asking it to be queen of spade exclusively, right? So let's say if I get this, I win the game, right? So I'm just calculating my probabilities in the head. Let's say I'm in the casino, and if I get queen of spades, I win, let's say $1,000 or something. I'm just thinking like, what are the chances? The chances is only 1 by 52, a very less chance, right? Now let me ask you another question since we are here. Now let me write it down so that you guys don't get confused. So from one deck of cards, take your time, don't jump to answer. Even if others answer, just try to understand like how did they answer. Probability of drawing one card. So I have one deck of cards and I'm drawing one card, and the card comes out as red. Sorry, red. The question is, listen to the question. So I have one deck of cards. Okay, I draw one card, and I'm asking what is the probability that the card will be red color.
1 by 2.
1 by 26. 26 by 52.
1 by 2.
26 by 52.
Keeping my 1 by 2.
One by total.
Okay, I think I heard one wrong answer. Okay, so the answer is 26 by 52, which is equal to 1 by 2. Okay, who told 1 by 26? Any doubt? Why did you? So first, there are 52 cards, right? So out of that, how many red cards are there? 13 plus 13, which is 26. 26 divided by 50. So like this, you have to keep practicing. If you don't practice, of course, you'll make mistake. As I've mentioned many times, I see only wrong answer because your denominator is wrong.
Can you once again repeat that question?
The question is, I have one deck of cards and I draw a card, and what is the probability that the card I draw, right, is red color?
Okay, yeah, got it.
Okay. Good that you guys are asking questions so that I know you guys are listening to the class. Okay, let's go to the next part. Okay, so whoever has any confusion, just try to think through it. Always come to the denominator and then start approaching the problem. Okay, now let's take this particular question. So this is an example of empirical probability. Can anyone explain why this is empirical probability?
We have prior data.
Right, so because this is a class of students, right? You don't know what is going to happen, who will take what class, right? You have to observe or collect the data. So that is because it is called empirical probability. Now, answer is there, but don't jump to it. Just take step by step. So find the probability of selecting a male, taking statistics from the population described in the following table. Okay. I'm going to read the question again. Find the probability of selecting a male, taking statistics from the population described in the following table. Now, what is this table? This table is defining as a class of people taking statistics, not taking statistics, and their gender, female and male. Okay. Now, what is the question? What is the sample space here? From the population, okay?
Total population.
Total number of population.
Right? So total number is 439. Okay, don't make mistake here. Denominator mistake, whole problem gone. So what is the question? What are the favorable outcome? They are asking
Male taking stats.
taking
So
stats,
it's 84.
right? So the denominator is 439 because it's total population. The numerator is basically the favorable outcome, which is 84. So basically these are the males who are taking the class, which is statistics. So basically 439 divided by 84. So the answer is basically 0.191. Any questions or doubts on this problem?
Mani, if I see that, first my mind will think on the population of male 229.
Right.
Because the question is like selecting a male taking statistics from the population.
Correct.
And it is not mentioned as overall population, but it's the population means whatever is that we should consider the overall total or how it is.
Yeah, so that's a good question.
Population.
Yeah, so generally if I ask you, probability of selecting a male taking statistics from males, I say from males, then you have to go for this because I have clearly mentioned that males. But generally what happens is they have given that population and clearly you know that the so think about this, right? So you enter a class, okay? There are, let's say there are girls and boys. So let's say girls and boys, right? So there are, let's say so many of them, let's say. Now the probability, think on this realistic situation. You asked one guy, it's like stand up. Now you ask, he's a male and he's also taking statistics. That is the question. So you ask one guy and you ask him to stand up and he's a guy and then he's taking statistics. Now you're doing this. Are you doing this among only males? Then you have to go the divider by 299. Are you doing this in the whole class where there are girls and boys? Then you have to divide by 439. You see the difference, right? So when the question is something like taking a male taking statistics from the population, whenever something like population comes, it is the total number of students. When the problem comes something like selecting a male taking statistics only from male population or only from males, then you go to a class, you already know that you have to select only males, right? That is already your very small subset. Then you have to divide by 229. Does that make sense?
Yes.
Okay. Any question or doubt on that? So generally you have to divide by population. Nobody will ask like what is the probability of selecting a male and then taking sex. Generally you go with the 430. So that is the only catch in this problem. Okay. Yeah, of course your brain will think, okay, I read male first and then statistics. So of course you will try to jump here. But the catch is take a moment back. What is the sample space? The class has girls and boys, all of them, right? So that is the population that you are looking at. Okay. Okay, I hope you guys are following through and you are seeing the confusion, right? So generally probability is simple only, but people generally get a little bit confused and things become a little bit confusing all the time. So take your time, take it step by step. So I'm also going slow. So
in current question, like from the population means it's taking, we are taking overall population. If specifically like if it is mentioned like male population, then we need to take 229, right? 84 divided by 229.
84, yeah, correct.
Okay.
If you remember also, that is the same problem again. Some people are getting confused. For example, here also, I confused you guys with, so what is the confusion is basically there is a simple event. We'll come to this. There is a joint event. Now, simple event has one characteristics. It's like queen or red or black card or let's say king. Joint event has the confusion. This is where you guys are getting confused. It is red color queen. You're like, okay, wait, so should I pick red color queen from red color cards? No, I'm saying I already have a deck of cards. My sample space is already fixed, right? So the denominator is 52 only. What I'm asking is basically, instead of a simple event, I'm asking a joint event. So joint event is basically red color queen. So where are red color queens? So this is one red color queen, and this is also one red color queen. Right? So you see the probability is again 2 by 52 only. Don't get confused. Okay, should pick first red cards, then again look for queens? No, that is wrong. I told I have a deck of cards, and I'm drawing one card, only one card, and I'm asking you a joint event. So joint event has two characteristics. One characteristic is the color, and one characteristic is the what is that? The word that is written on the card. Now, till now, you had no problem finding the probability of simple event. If I ask you what is the probability of drawing a 5, so you go here, okay, 5, 5, 5, 5, so total 4 divided by 52, 4 divided by 52, no problem. But when I say draw a card which is 5 and black, that's where you're getting confused, because you're thinking, okay, should I pick only from the black? No, you already have a deck of cards laid out here. So your sample space, your divider is already 52. What I'm asking you is basically a joint event. So joint event has two characteristics. One is number 5 and one is color black. So how many of them are there? So 5 of spades and 5 of clubs. So you basically 2 by 50. Okay, I hope that is clearing some of the confusion. So here also I'm asking the same confusing question. So that is basically, what is the probability of selecting male taking statistics? So two characteristics.
So for joint event requirement, minimum 2 characteristic will be required.
Yeah. So simple event is only one. What is the probability of selecting male? Joint event is basically male and taking statistics. So two things we'll come to that. Yeah, that's correct.
Okay.
So let me go. So this is again. So that's why I'm trying to explain as much as possible, because sample space, this is where everyone will make mistake actually. So this, if you make mistake here and everything is gone actually. So because denominator is wrong, so answer is definitely wrong. So always define your sample space. Forget about the question, right? Forget about question. What is the sample space? I can pick anyone, right? From the population. So it could be male, it could be female, it could be statistics, it could be not taking statistics. I don't care. Then I have to come divided by 439. Then you start with the problem. Okay, males and statistics. Then you're okay. Once you keep practicing, you don't worry. Okay, so this is basically I don't know why this is there, but yes, the sample space of dice is this. Deck of cards is 52. Let's say if you're having a child, then it is boy or girl. Okay? Now, this is what I was explaining. So simple event is basically an outcome from a sample space with one characteristic. Okay, characteristic here is color, a red card from a deck of cards. Complement of an event denoted by a dash or a bar actually, so something like this. So this is the denotion of complement of an event. So complement. So complement of an event. So complement of an event is all outcomes that are not part of the event. Complement of an event is all outcomes that are not part of an event. Okay. What is the example? All cards that are not diamonds. Now, what are those cards? All cards that are not diamonds is basically where are diamonds? Yeah. So all cards that are not diamonds. What do you end up with? So this is
39.
So I just remove these guys. So all cards. So these are all the candidates. So all these cards are your candidates. All cards that are not diamonds. So that is a complement of an event. Okay. I hope you guys are following. Joint event is where we are having confusion. Involves two or more characteristics simultaneously. An ace, that is also a red from a deck of cards. Okay. Ace. How many aces are there first? Okay. So you have ace, 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 ace. And ace is done. They are also asking, that is also from red. Right. So these are the two ones. So this one is one. And this one is one. Since they are black, they are not even your required ace. Okay. So these are the two characteristics that we are looking at. One characteristic is the word A, and one characteristic is the color A. So this is a joint event. So this is where I think you guys are having confusion. Okay. So any doubts on this nomenclature or like the definitions so far? Any questions till this point, like whatever we have discussed? Like simple event, joint event. What we have discussed so far is simple event, joint event, a priori probability, empirical probability. So very basics. Like probability can only be between 0 and 1, and summation of all the probability will always be 1. Okay. Let me go to the next part. So this is just for the visualization. Whoever is getting confused. Now, I hope this doesn't confuse you even more, but contingency table is basically trying to break down this in the visual form into a table. I've just written this whole thing into a table. Now, how I can write this? I can write this deck of cards of 52. So 52 cards are there total. So 52 cards are there total. I can break them down as either there are A's or either they are not A's, right? So what are the, so this is your character quality or the characteristic. So character meaning A, 1, 2 or Jack or Queen. Now this is your color. So this is your color. Cards I am just breaking down. So there are total of 52 cards only. I'm just breaking down. There are two cards which are black and which are Ace. Okay. There are two cards which are black and which are Ace. 52 cards I'm just breaking down. That's all. I'm not doing anything, so that it will be easy, or maybe you guys can understand better. So how many red?
What is Ace means?
Ace means the number A. Sorry, what is the question?
It's, what is denoted by Ace? Ace.
Ace means this particular card, which is A.
Okay.
This is generally called Ace. This is Jack, this is Queen and King. So J stands for Jack, Q is Queen.
It's the face cards.
Yeah. No. Ace is only A. Only this card, these 4 cards, that's all. I'm just explaining or giving the explanation of what does this A stand for.
Okay.
Okay, A stands for Ace. That's all. Short form of Ace is basically. So there are total of, there are 24 black cards which are not Ace, and 24 black cards which are not, red cards which are not Ace. So this is 26. Now why this is given? Because let's say if you want to approach any problem, you can approach this particular problem in this manner. So generally you can, where is that problem? So let's say you can define like how many black Ace are there when you draw a card from one deck. So answer is 2 divided by 52. Right? Directly you can approach that. Summation of all probabilities is always equal to 1. Okay, so that's a high level question. Why is it 1 is a good question, but let's take this. Okay, so let's take these questions, right? So it has to be 1 because now let's take any example. I'll explain in the observation manner. So what is the problem? So when I flip a coin, when I flip one coin, the probability of heads is 1 by 2. The probability of tails is 1 by 2. Now let's forget that the summation is 1. So let's say this particular example, I add the probabilities, probability will become 1. Okay, I don't know, like I'm just scientist, I'm just trying to figure out is it actually equal to 1. Now when I roll a dice, so when I roll a dice, actually what happens, the probability of 1, 2, 3, 4, 5, 6. So the probability is 1 by 6, 1 by 6, 1 by 6. Now here also when I add all the individual probabilities, the probability will be 1. Okay, so 1 by 6, 1 by 6, 1 by 6 also 1. So let's say if I take this deck of cards, the probability is again 1 by 52. Now again, if I add all those 1 by 52, 1 by 52, 52 times, the probability will be 1. Now this is a simple explanation. The theoretical explanation is the probability, the summation of probability will be 1 because one of these events will always occur. Now basically any of these can occur. For example, 1 patient can come, 2 patient can come, 3 patient can come. So what would happen is you end up adding the probabilities of 1 by 2 plus 1 by 2 or 1 by 6 plus 1 by 6 plus 1 by 6, because when when you roll a dice, it has to land on among one of these, right? So any of these, for example, 3 or 4 or 5 or 2, right? If the question is, if I roll a dice, what is the probability that it will either land on 1, or it will either land on 2, or it will either land on 3, or it will either land on 4, or it will either land on 5, or either it will land on 6. So the answer is 1, because it has to land on one of these, correct? It has to land on one of these 3 or 4 or 5 or 6. But if you do this traditionally, this is basically 1 by 6 plus probability of 1 plus probability of 2 plus probability of 3, like that, some or total to 1 by 6. So total 1 by 6 times 1 by 6, which is equal to 1. Now what you're trying to ask, what I'm trying to explain is, one of these events has to occur. So that's the reason the summation of individual probabilities will always be equal to 1. I hope I was able to explain. M. Shankar Lal. Is that correct? I'll ask that question.
Yes, yes, I got it. Yeah.
So one of them always has to occur, no? So that's why the probability.
So is it something related to binomial distribution theorem as well?
We'll come there one by one. Let's
Okay.
not all of like there are many concepts, one by one. Right now we only know discrete and continuous. Slowly we'll know all the other things.
Okay.
Now what is this? So here we have definitions of simple and joint probability. So the simple marginal probability refers to probability of simple event, probability of king. Joint probability is basically king and spade. Okay, so how many? King and spade. So where are king? So king. There is only one spade. King of spade is only the last one. Okay. So that is your joint probability. Now this is a little bit confusing. Take some time. So mutually exclusive events are events that cannot occur together. Okay. So example, a queen of diamonds, a queen of clubs. Okay. Events A and B are mutually exclusive if only one card is selected, right? So when you select a card, it can be either queen of diamonds or it can be either queen of clubs, right? So both of them cannot occur. Okay. Now this might be confusing. A simple example is, let's say if you are having a child, either you will have a boy or either you will have a girl. It doesn't make sense, right? So you have both of the kids at one shot, but let's ignore that situation. But in general, you only have one of that. So when this is happening, B and G, basically having a boy and having a girl, are mutually exclusive. If one event occurs, the other event cannot occur. Is it clear? So if you flip a coin, it falls on head, it means that tails cannot occur. If it falls on tail, it means that head cannot occur. Okay, so that is basically an example of mutually exclusive event. I hope it is clear. Any questions on this?
No.
Right? In simple terms, it's just like, think of this example like having a boy or having a girl. You can either have a boy or girl. Generally, let's say you're only having one kid, so generally you cannot have in one shot. Okay, so that is mutually exclusive events. Okay. Now so these are just general definitions. Just try to remember them. So collectively exhaustive events. So one of the events must occur. Okay, the set of events covers the entire sample space. Okay, so what does this mean? So let's say if you take an example, so A equal to Ace. So the event A is basically Ace. The event B is basically black cards. The event C is basically diamonds, and the event D is basically hearts. Okay, events A, B, C, D are collectively exhaustive. Okay, what it means is, so let me explain. So collectively exhaustive means, so what is the first event? Ace. So let's say I keep these event A is basically, so I keep all of these cards here. So this is event of A. So this is basically event A. Okay. Now what is event B? Event B is all the black cards. So all the black cards are this one, okay, plus this one. So these are all the black cards. That is event B. So event B denotes black cards. Event A denotes all the A's. Okay. Now what about C? C is diamonds. So diamonds. So C is red. Let me pick. So this is diamonds. So this is event C. So the one in the blue color is event C. And this is your event C. Okay. Now what is the last one? D is hearts. So if I pick heart. So this is your event D in the white color. Okay. Now this is your event A, basically drawing a ace card. Okay. And what is the next one? Next one is drawing a black card. This is basically this black line over here, and this black line over here is your black line. Event B. What is the event C? Event C is basically drawing a diamond card, and event D is basically drawing a hearts. Okay. Now what collectively exhaustive means is when you add A plus B plus C plus D, you get the whole set, right? So when you add these 4 cards, right? So when you add this ace, and then when you add this black, and when you add this black, and then when you add this ace of hearts, and then you add this ace of diamonds, totally you get back 52 cards again, right? That's what basically means collectively exhaustive. So what it means is when you add these events A plus B plus C plus D, you get back the total sample space back, right? You get the entire sample space. So that's when it is called A, B, C, D are called collectively exhaustive. Any question on this? I think you guys didn't understand. Who understood this question?
Yeah, understood.
Okay, only Mahesh understood from the whole class.
It's clear, Mani.
Now, if we add B, C, D event, that time also it is all 52 cards.
So what is that? Again, repeat. B, sorry. Someone told a good point. Yeah, that is also correct. Even B, C, D,
C and D.
B, C, and D is also collectively exhaustive. When you club all of that, you get your deck back, right? Because the event A is repeated again. A is again coming again and again. So that is also a good point, right? So it doesn't mean in that way, but A plus B plus C plus D is also giving the whole set back, right? The whole sample space. Then also you can say it is a collectively exhaustive event. Okay. Now mutually is collectively exhaustive, and also mutually is basically B, C, and D.
Okay.
B, C, and D is basically, or let's make it simple. So red and black. Okay. Now red and black. So let's say event A is basically red color cards. Event B is basically black color cards. Okay. When I add red and black, do I get sample space? Yes, I get all the 52 cards, which is collectively exhaustive. Now, if I draw a red color card, can it be black color? No. If I draw a red color card, it can be only red color card. And if I draw a black color card, it can only be black color card. So that is why A and B both are called collectively exhaustive and also mutually exclusive events. Okay. If one of the event occurs from, let's say, A, it cannot occur from B, then it means that it is mutually exclusive. And if I do A plus B and I get all of the sample space back, then it is called collectively exhaustive. I hope these 2 points are clear.
Yes.
Any question or confusion on this? This is theory. Generally, you don't apply that. You just generally use it in the coming slides. The main idea is to sort of understand and come back to that. Come back to this is mutually exclusive means having a boy or girl. You cannot have both at one shot. You can either have a girl or you can either have a boy. Collectively exhaustive is when you add A plus B plus C plus D, you get 52 cards or sample space back. So that is your collectively exhaustive. If you remember these 2 simple sentences, that is also fine.
So the probability of collectively exhaustive event should be 1.
Yeah, that is correct. Okay. Now, some more theory I'll explain, and then I'll explain the problem so that you guys will understand. Now, probability of a joint event. Okay, probability of a joint event is basically event A and B is given as probability of A and B. So, which is generally given as number of outcomes satisfying A and B. Okay, divided by total number of elementary outcomes, which is total number of sample space. Now, what they are trying to explain is they're trying to connect the dots between. They're just trying to connect the dots between. Can you write the joint event? Can you write the joint event in terms of simple event? So that's what they are trying to explain. Yes, the answer is yes. So the way you can write is basically probability of A. Let's say if B is another event that is present, is directly proportional is equal to probability of A and B1 plus probability of A and B2 plus so on probability of A and Bk. Now probability of A is basically a simple event, simple probability or a marginal probability. It can be written as probability of A and B1, where B1, B2, so on Bk are K mutually exclusive and collectively exhaustive. Now I'll explain in simple terms. So let's say so I hope you guys are trying to connect the dots. So let me clear this first. So the first thing that you guys have to understand is, first, can you calculate probability of a joint event? So joint event is given by A and B, two characteristics, color and name, let's say. It is given by, simply it is given by, so let's say if you ignore this below one for now, you can directly find the formula money. I can find out number of outcomes satisfying A and B divided by total number of outcomes. So that is what we are doing from the, let's say if it is a red color card and a number 4. So you go here, red color card, okay, red color card, where are red color cards? This is a red color cards, this is a red color cards, 4 and 4. So the answer is 2 divided by 52. So that is what we were doing till now. Now what they are trying to explain is, they are trying to explain that can you figure out the can you try to break it down into or try to connect these two? What are that you are trying to connect? You're trying to connect a simple probability, and can you write it down in the terms of a joint probability? Yes, the answer is yes. You can write it down. The answer, the way you can write it down is, if you have another event or another characteristics which is B1, B2, so on Bk, where B1, B2 and Bk are K, let's say K mutually exclusive and collectively exhaustive events, then yes, the answer is yes. You can write the probability of A in this particular manner. I hope you guys understood this, or maybe you understood something out of this. How many?
No.
Okay. So what I'm trying to explain is, let's say the probability of so let's say you have a deck of 52 cards. So this is your 52 cards, and you draw one card. Okay, the probability of spade. So how many spades are there?
13. 13.
13.
13.
Where did this go? Okay. So probability of spade. Is this a simple event or a joint event?
Simple event.
Because only one characteristics. Okay. Now let's write it. Can be, so what is the probability? We have 13 spades, and what are the total cards? 52. This is what I'm explaining. This is, you can write this. You can write this as probability of simple event. You can write this as probability of spade and ace plus probability of spade and number 2 plus, I hope you guys are seeing where I'm going, probability of spade and number 3, like this, dot, 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 king, queen, and jack. Okay. This probability of spade is a simple event, can be written as K1. So K here is 13. Actually, let me, where is that whiteboard? One second, let me, okay, let me explain here only. So probability of spade is a simple event, which is basically given by 13 divided by 52. Till here, no confusion. Now, what they're trying to confuse you is, you can write this as, this particular probability, you can write this as, so how many K mutually exclusive and collectively exhaustive events are there? 13 of them. What are those 13? If I want all the spades, I can actually collect this one, this one, this one. So all of them I collect one by one by one by one. So I get 13 spades, correct? And if I draw a card, if it is 3, it cannot be 5 at the same time. So which means it is mutually exclusive. Okay. Now what in simple terms they are explaining is, this probability which is 13 by 52, you can also find it as probability of spade and being ace plus probability of spade and number 2 plus probability of spade and number 3, which is basically 13 by 52 is basically your simple event probability on the left hand side. On the right hand side, what are the probabilities that you have, which is equal to 1 by 52 plus 1 by 52. So how many times? 13 times. So that is what is happening. So let's say dot, dot, dot. So dot, 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 like this, 1 by 52, 13 times. So this whole thing is basically 13 times. Now you're able to do this because you're able to break down this spade of cards into K mutually exclusive, collectively exhaustive events. So what are those K mutually exclusive? K number is 13. Collectively exhaustive because if all of these events occur, so let's say ace occurs, 2 occurs, 3 occurs, 4 occurs, what is the, if you add all of them, you get back all the spades. And if 2 occurs, 3 cannot occur. So that is what they are trying to explain. Now is it clear or better?
Yeah, clear.
Yeah, makes sense now.
They're just trying to confuse you. That's all. So simply, so what this is in general, you don't go this deep in probability, but it's a good idea to know what is what. So they are just trying to rewrite this probability of a simple event in terms of joint event. That's the thing you have to remember. That's all. Okay, probability of a simple event. They are just trying to break it down into collection of joint event probabilities. That is only possible when you have B1, B2 like that, BK, K mutually exclusive and collectively exhaustive events. Then only you can break it down. That's all. That's the thing you have to remember. Okay, you can rewrite a simple event as a summation of collection of joint events. Okay, we'll see an example. You guys will understand. One more example is there on this. Now, example of joint probability. Probability of red and A is basically 2 divided by 52. At the same time, probability of ace is basically 2 divided by 52 plus 2 divided by 52. If you are getting confused in this simple and joint probability, just forget about this. Go to this diagram, remember, and you can answer both of these. You don't have to come from joint probability to simple probability. Okay. Now this is an important table. Now this table is called your contingency table. So what you have to remember is the probabilities that are in the center, these ones, right? So these one, this one, and this one, and this one. These are your joint probabilities. Okay. Now the probabilities on the boundary are called your simple probabilities. Now, can you guys connect this to any example that we have discussed so far? So we have discussed one similar example on this. Okay, so let me explain it again. So the probabilities.
Males getting statistics.
That is if you come here, yeah. So simple answer. So these are your joint probabilities. So whenever you find probability of a male taking statistics, something has to come in your mind. Okay, Mani, this is a joint probability. So I'll basically find the probability here. What is the probability of a male? So basically this is your simple probability. So 229 divided by 430. That's all, 50% or close to 50%. Okay. Now these are your simple probabilities or simple events or simple probabilities. And these are your joint probabilities, so the inside ones. Okay. Now the ones in the black are your simple probability. So this is a simple probability. This is a simple probability. What I mean by that is, what is the probability of female? So that is a simple probability. What is the probability of a person taking statistics? Simple probability. What is the probability of a person not taking statistics? Simple probability. Joint probability. What is a probability of female not taking statistics? There are two characteristics. I am coming inside this block, so which is where this is joint probability, and these ones are your simple probability. Now the summation is always equal to 1. Right? So that is what they are trying to explain in this particular example. So the same thing you can visualize here. Okay. Any questions on this? So this way you can try to break it down in simple terms and then you can understand. Okay. Now I think we have some basics covered in probability. So I'm going to sort of maybe wrap it up to some extent. So probability is the numerical measure of the likelihood that an event will occur. The probability of any event must be between 0 and 1, inclusive of 0 and 1. The summation of the probabilities of all mutually exclusive collectively exclusive events is equal to 1. When you add all of those individual probabilities, the summation will be equal to 1. Okay, so till this point, these are all the basic probability questions that we have discussed, right? So basic deck of cards. So mainly your questions generally will come when you give interviews or something like that. They'll just directly ask you like, hey, I have just a deck of cards. Can you explain me what is the probability of getting an 8, right? So that is a simple probability, right? So there are 4 8s. So there is 4 divided by total 52. No confusion. They'll ask one more question. Okay, it looks like this guy knows probability. So what is the probability of getting an 8 of heart, right? So there is only one, you know, among the 52 cards. Like that, there is only 1 8 of hearts, right? So the answer is 1 by divided by 52. So that's all you have to generally. That is the extent generally they go in interviews, because the interview is not about probability, right? So it's about machine learning and data science, but the basics is important. So you need to understand what is the basics. Okay. So till this point, I hope you guys are clear. What is a basic probability? What is a simple probability? What is a joint probability? Given a question from a deck of cards, I hope you guys can solve problem properly. Do not jump to the numerator. If you jump to the numerator, I can write it down. It is wrong answer. Always start from the denominator and understand the question first. Take some time. It looks very, very easy actually. Like probability is like very simple English, but in 1 second they can confuse you. So take your time, take some time, and then try to come with the denominator and come with the numerator. Then you will get the correct answer. Okay. Now let me explain some more basic questions. So there are some general addition rules. So addition rule is basically probability of A or B is given as, so this is a formula. Probability of A or B is given as probability of A plus probability of B minus probability of A and B. Okay. Now you can think of this in terms of Venn diagrams. So let's say this is a one Venn diagram. So this is a event A, and let's say this is event B. So let's say this is A, and let's say this is B. So general addition rule, right? So probability of A or B. So it means it can be here or it can be here, which means probability of A. So you add this. Probability of B, you add this. But doing so, you added this part 2 times. So that's why you subtract it 1 time. So you get the answer. So probability of A plus probability of B minus probability of A and B. Okay. If A and B are mutually exclusive, meaning let's say if you're having a child, it is boy and girl, probability of this is generally 0. So the diagrams look something like this. So if it is a mutually exclusive, it is like this. They do not have any intersection. So this is A and C. So this number will become 0. So the probability will be A or B is actually equal to probability of A plus probability of B, only for mutually exclusive events. Okay, only for mutually exclusive. For normal events, let's say probability of A or B is generally given as probability of A plus probability of B minus probability of A and B. Okay, so this is called your general addition rule. Okay. Now, let's see this in action. So we have already solved that. So let's try to understand this in action and try to understand if we can. Let's see how many people understand this. So find the probability of selecting a male or a statistics student, okay, from the population described in the following table. Before even jumping to answer, how many guys understood the question?
Yeah, it's basically male and total number of statistics students.
And nay or?
Oh, sorry, or.
Gone. They're only gone. So you see, right? So take it step by step. So that's what you guys will slowly make mistakes. So take it step by step. So the question is probability of male. So let's say you go to a class and you pick a student. What is the probability that he's a male or he is taking statistics? That is the question. I hope the question is clear first before even going to answer.
Yeah.
Male or a statistics student. So P of male or a statistics. Probability of male is a simple event.
229 divided by 4.
The thing is actually a joint probability. So this is because you're looking at two characteristics. Now you can come back to the general addition rule formula. Probability of male or stats is basically equal to probability of male plus probability of statistics minus probability of male and statistics. You can go back to the general addition formula. You can write this in this particular manner. Now, what is the probability of male? So the total number of males are basically 299 and the divisor is always 439. So from the population, okay? Don't get confused, from the population. So 229 divided by 439. What is the probability of male? Total number of males divided by total number of students. Right? 229 divided by 439. What is the probability of people taking statistics? How many people are taking statistics? 160. Total number. Okay, 160 divided by 439. Now, what is the probability of males and statistics? So that is basically your probability of males and statistics, which is basically equal to 84 divided by 439. So this problem we have already solved. The first one, probability of male and statistics. So 84 divided by 439. So the answer is 305 divided by 439. Okay. Any questions on this? So we solved this in the beginning of the class. What is the probability of male and statistics? What we are solving is you pick a student and he could be male or he is taking a statistics. We are using the general addition formula and we are coming up with probability of male plus probability of statistics minus probability of male and statistics. Okay. Don't get confused. The denominator will be 439 only. Do not get confused. Any questions, any doubts here?
So here male and that statistics is mutually inclusive, not exclusive.
Mutually inclusive, yeah. Because there are few students who are males and are also taking statistics. Let's say,
yeah,
situation only males are taking, let's say, basketball, and females are playing, let's say Coco or something. Then that is mutually exclusive. You don't have any intersection. M and I hope you guys are with me. So, okay. So simple addition formula. You don't have to get confused a lot or all that. If you're getting confused, go back to this formula, money. This is the formula I know. Just write it down. Go back here and this is this. So we already discussed that any probability inside this is a joint probability and any probability on the boundary is your simple probability. So these ones are your simple probability.
So whenever that joint probability means question will be arise, including that or, then we will consider this formula.
Yeah. If your question is or.
Yeah, got it. Thanks.
So, okay, so let me go to the next slide then. Now this is where confusion comes in. Already it's confusing, so some more confusion. So I'm going to explain this and then maybe we can pick it up in the next class slowly. Now, if you remember in the beginning of the class, I've explained a flow. So random variable, then probability, then conditional probability, then Bayes theorem, and then naive Bayes. So that is the connection with machine learning, right? So the conditional probability is important. So you guys have to understand this. Now I'm going to explain in simple terms. So just let me know if you guys have any confusion. So a conditional probability. Okay. So till now we have discussed simple probability, joint probability. Then we discussed about collectively exhaustive events, all those things. Simple event, joint event, all that. Now what I'm explaining is basically your conditional probability. Okay. A conditional probability is the probability of one event given that another event has occurred. Okay, conditional probability is the probability of one event given that another event has occurred. Okay, now what is the event that is occurred? Event that is coming in the denominator. So this event is already occurred, and there is some relationship between the event A and B. Okay, so what it means is, so let's say the event B has occurred, and occurrence of B actually has some effect on occurrence of event A. Then, Mani, I know that these two events have some effect on each other, and what I'm going to do is basically I'm going to compute conditional probability. Now, why will you compute conditional probability? Because now this word, so this word is very, very important. So this word, whenever you see that word, the word is called given that. Whenever you come across this particular word called given that, then you know that Mani, I have to calculate conditional probability. Okay. Now conditional probability is denoted by P of P. This bar is called pipe, so which is called PIP. So A pipe B. So which means P of A pipe B means probability of A given that B is already occurred. B is already occurred. I know the occurrence of B has some effect on A. So then this is called conditional probability. So how many people understood this? We'll see one example, you guys will understand.
So that event A and B should be mutually inclusive, not exclusive.
Yeah, there is some effect. That's what I'm saying. So there is some effect. If there is no effect, then there is no conditional probability.
Okay.
So probability of A is part of probability of B?
Not part of, it has some effect. So what I mean by that is, let me explain. So I'll give an example. I think you guys will understand. So let's say, okay, let me write it down actually, or else you guys will not understand. So let's say the event A is basically from a deck of cards. So let's say one deck of 52 cards. So I have 152 cards deck. So event A. So I'm defining event A. Event A is basically what is that? Select. Let's say select 4 of card. Now event A and remove that card. Just for the example, we will not compute probability. Remove card. Remove that card because this is event A. Now, what is event B? Event B is from the same deck. From the same deck, let's say select 4. Okay. Now, can you guys see what is the effect of A on B? Can anyone tell me what will happen? I have.
First we had a 52 card in a deck, so one we have removed. So next time the sample space will be 51.
Right. Now what it means is there is some effect of A. When I calculate the probability of selecting 4, I know that out of 52 cards, I know that 52 cards are reduced to 51, and there are only 3 4s in that. Right. So the probability is 3 by 51. Right. So what I'm trying to explain, so you can just ignore that probability for now, but what you have to understand is, so what you have to understand here is the event A has some effect on B. right? Now, what I'm trying to explain is, so when such events occur, right? So the way you define that is probability of B, given that A has occurred. So P of B by A, because A has already occurred. When I selected a 4 of heart and I remove that card, what is the probability? And I remove that, right? So this A has some effect on B, right? So this is where your conditional probability will come into picture. Is this example clear? Now, because of this A event, the B doesn't have 52 cards anymore. The B has only 51 cards, right? And then 1/4 is already gone. So there is only 3/4 remaining, right? So that is the effect or the conditional probability that I'm trying to explain, right? So one event has effect on the other event in that manner. So we'll take one more example, you guys will understand. Of the cars on a used car lot, 70% have air conditioning. Okay, 70% have air conditioning. 40% have a CD player. Okay, 20% of the cars have both CD player and AC. Now, what is the probability that a car has a CD player given that it has AC? Okay. Now, before even jumping into the answer, can you guys tell me, like, is it conditional probability or not?
Is conditional.
Okay. Because even if you don't understand any of this, I can see that Mani, there is a word called given that, and I know that there are two events A and B. Mani, I think this looks like conditional probability before even jumping to answer or anything. Now, this word is important. So given that, whatever, like it has AC. Okay. So let's break it down into simple terms. So 70% have AC, 40% have CD player, 20% have both. One event has already occurred. What is the event that has occurred? It has AC, so it will come in the denominator. And what is that you're looking for? Probability of a car that has CD player, so it will come in the probability of CD. This is the denotion and how you break it down. Okay. Once you break it down, let's see how to solve this particular problem. So the way I'm going to solve this is basically, so they have given that 70% of the cars have, if you go back to this formula, it is very simple. So the formula is P of A by B is given that P of A and B divided by P of B. Now if you come back to this, P of CD by AC, sorry, P of probability that, probability of selecting a car which has a CD player, given that it already has AC, is given by probability of CD and AC divided by probability of AC. Okay. What is the probability of having AC? They have given 70% of the cars have AC, so 0.7. What is the probability that they have both CD and AC, which is 20%? So the answer is 0.2 divided by 0.7. So the answer is 0.28. Okay. Or you can build this table. You can build this table to make it more clearer for you. Now, there are two options in case of AC, and there are two options in case of CD player. Okay. They have given 70% of the cars have AC. So 30% do not have AC, because the total probability will always be equal to 1. Correct? Now 70% have AC, 30% do not have AC. They have told that 40% of the cars have CD player. That means 60% do not have CD player. Okay. So you have computed the simple probabilities or the boundary probabilities. Okay. Once you have done that, you go inside and find the joint probabilities. So they have given 20% of the cars have both AC and CD. So 20% is here. What is the remaining? 50%, because sum of this should be equal to this. So 50% is here. Now you know this is 0.4, right? So it's like a fill in the blank or a miss, that in childhood you used to have that, right? So you have this one, this one, this one. So this is 3 and this is 6. So how will you write this? You write 1 here and 2 here. You already know what is the total sum. So you keep on filling this. Okay. If you are getting confused with this, formula, you can fill this particular table. So that will give you more picture and what is the question that they are asking. If you're like, Mani, I don't want to build this table and this is even more confusing. So just go by the formula. What is the formula? the formula is probability of A given that B has occurred is given by, so this B will come in the denominator, and what will come in the numerator? P of A and B. Now if you go back to the question is probability of CD and probability given that AC has occurred. So you just have to write probability of CD and AC. So probability of CD and AC. So what will come in the denominator? Denominator is basically probability of AC. Now what is the individual probability? Probability of AC is basically 70% of the cars have AC. So basically this is 0.7. And probability of having both CD and AC is basically 20%. So 20% of the cars have both. So which is 0.2%. Well, let's say after 2 days, or let's say after 1 month or something, you got confused and you came up with this formula. Let's say, don't get confused with this, but I'm just explaining how to come out of the danger. So let's say you come up with this formula, you got confused and you gave this, and the probability will come up to 3.5. Now, is there a way you can, from the theoretical knowledge, you can say that Mani, I made a mistake here? Can anyone tell me like what you can think so that you can correct yourself?
Probability can never be more than 1.
Exactly. So let's say in some random case or some problem solving, something you forgot and you made some mistake, and your probability is coming greater than 1. That means that your computation is wrong. You have to go back and then do something is wrong. Right? So this is a nice way. Generally, I remember that, okay, if I'm calculating probabilities, if I forgot the formula, if I'm getting probabilities greater than 1 and the summation of individual probabilities is not equal to 1, that means that I am making a mistake. That is the general way you can remember. Like if you're making any mistake, generally, okay, probability cannot be greater than 1 or less than 0. So that's how you can correct yourself. So you forget this part, and what you come back is here. Okay, this is the correct part. Any questions or any doubt on this part, like how to compute the conditional probability?
No, clear.
So for that same question, if that AC means air condition and that CD player, that 20% part will not be mentioned in the question, then what will be the output?
So that is right. So if that is not there, you cannot come up with this table. Let's say if that information is not there.
Yeah.
20% of the cars have both. So let's say that is not there. So what you end up drawing is this table. You would end up drawing this one. You know that 0.7 here. You know 0.4 here. That's all. That you cannot do anything. So this is 0.6 and this is 0.3. So you just compute the boundary ones, but you do not have any information here. They have to give at least 1 point among this so that you can fill the remaining.
Okay.
Yeah, Mani, conditional probability will always have maximum of 2 events, right? If I'm not wrong.
No. More than 2 is your Bayes theorem. We'll come in the next class. Like slowly we'll extend.
Okay.
That's a good question. So here, Mani, I only have 2 things. Can there be like 1, 2, 3? Yeah, the answer is yes. So that is your Bayes theorem and your machine learning. So that is the end of the spectrum. That is where you start learning about Bayes theorem and conditional probabilities. So conditional probability, that's a good question. So conditional probability involves 2 events. And anything more than 2 is called your Bayes theorem. So we'll see Bayes theorem. So 3 or 4 or 5 or 6. Basically, this formula will become more and more complex. That's all. Here there are like very simple formula. Probability of CD given that AC is already present is. So this one. Okay, so any questions? So I'll close the class today. There is 10 minutes. If you guys have any questions, if you are hesitant of asking questions, you can ask now. The class is done. Any questions, any doubts, or anything that we have discussed today? You have any questions? You guys can ask me. So I'll upload this. I think I've already uploaded it in your Google Classroom. I don't know how it looks for you, but I'll upload this today again. So you guys can go through this, work on some problems. Always remember, don't get confused with any of the words that they give. Start with your denominator and come to your numerator. If you start with your numerator, then your brain itself will trick you, and it is very easy to make mistakes. Probability is simple only, but it becomes a little confusing when 2-3 things come at one shot. Try to break it down. If possible, if you already have a formula in your mind, just directly go and apply that formula. No need to understand or think or build this table. If you remember this formula, directly go and apply this.
So to understand the occurrence of that card event, need to understand that all the 52 cards before.
Yeah, you need to know, like generally this picture you should remember, like, or else it will be difficult. You cannot answer anything. So suddenly they'll come and ask you what is the probability of face cards and which are red. So if you don't know what is a face card, then it is difficult to answer, right? So generally this picture you have to remember, like for probability.
Yes, yes. What link do you clicked
Sorry?
to get this image?
This I got from some casino website or something.
Okay, okay.
You can just directly search like the deck of cards, and then you will find in the Google.
Okay, okay. Thank you.
Yeah. I hope you guys got a chance to learn some basics of probability, like how to, let's say if you're playing any games with your friends in your home, then you can see, okay, how probability is applicable there. Let's say you're playing Rummy, or let's say 21 Blackjack anywhere. You can see, okay, the probability of red. So let's say in front of you, you can see, let's say two fours, right? You can figure out, okay, there are only 2 remaining, and there are like 50 or let's say 30 cards in the deck remaining. So, okay, there is some decent probability. Let me try it, something like that. So you guys can start connecting like that.
Yeah, Mani, from tomorrow, like what are we going to cover the days after? No.
So I think probability will take 2-3 classes. There's a lot of things in probability actually. One second. So the basics are done. We will discuss about, I think, Bayes theorem, and then we'll discuss more about the connection between probability and distributions, binomial distribution and all that. Okay. Let me check actually. Yeah, we'll discuss Bayes theorem, and once we discuss Bayes theorem, then there are some basic questions that you can do, and then we'll discuss binomial distribution. Tomorrow we'll discuss Bayes theorem and binomial distribution. Okay.
Hello, Mani.
Yeah.
Yeah, where will you be uploading these this one documents and all?
I am uploading in your Google Classroom. That's what they have told.
Could you share this link once?
What?
Could you share the link once in the WhatsApp group?
Yeah. This is. So this is where I have uploaded the previous. So Friday 12th June, you can see here. So.
Okay, could you just give us the code? Is it there in the WhatsApp group?
I think it is there in the WhatsApp description. So generally, all the information about your class will be present in your WhatsApp group description. If you click on the WhatsApp group description, you'll find it. If it is not there, I'll share.
Fine.
It's there in the WhatsApp group description. Drive link is also there. Yeah. Okay, guys, then I'll close the class. I think if you don't have any other questions or doubts, I'll talk to you guys tomorrow.
Thank you.
Yeah, Gayatri, thank you. Talk to you tomorrow. Bye-bye.
Bye.